Been in data science now for over a decade. Made a lot of realizations. Definitely made some mistakes along the way. But these are my 7 biggest realizations that changed the trajectory of my career, made me more successful, more valuable to companies. It's the reason why I've been successful in attracting clients. Understanding that the perception of data science and the perception of the data scientist role is completely different than the reality of it. So these 7 data science truths were the ones that once I understood them and internalized them and accepted them, I was able to become a much more valuable data scientist. It's what propelled me forward in my career and made me more successful. The first one, we focus on math, stats, code. Those are the easy parts. As crazy as it sounds, that's the easy stuff. What goes into building a reliable model that gets deployed, getting it into production, getting people to use it, that is far more challenging. If you wanted to focus your career on something that would make you exceptionally valuable, you have to know how to write code. But what kind of code do you need to know how to write production grade? So what does that change? It's a focus on more foundational software engineering and systems design constructs. You have to know math and statistics. But why? Well, it's to get models into production. Well, so what? That changes the focus. Now it isn't just how does my model perform? What are my accuracy metrics? It's using your background in math, your understanding of the way that the model works itself to make the model explainable, transparent, and to start building that support for the model functioning, not just on your data set and on the training data set, but in production. When it gets deployed, it has to have a level of reliability. And that changes the way that we use math, the way that we apply statistics to understand model performance. Completely different focus. Explainability, reliability, creating an evidentiary support, not just a little mathematical one. We're not doing statistical analysis just for the sake of statistical analysis and p-values. It's completely different in order to get it into production. Next, in order for me to deliver successful products, yes, definitely, I had to understand the data. I had to focus on the data, but there was a second dimension that I was completely missing. I need to know my users just as well as I know my data. Why? Again, this goes back to I'm getting it into production and it has to work for someone. It's producing a value, an outcome. It's not just a model, but that outcome is being produced for a person. There are people involved in the process. And I can build the most effective model on earth. I can build a cool front-end application or great reporting, wonderful usage of color. It doesn't matter if they don't like it. If I don't understand them and how they plan to use whatever it is I'm delivering to them and the problem they need me to solve or the functionality they need me to deliver to them, if I don't understand that, it doesn't matter what I deliver. It will fail. My project will not be successful. So I need to understand my users just as much as I understand my data. There's no such thing as a unicorn who succeeds in data science. The myth is still out there that you have this full stack data scientist. It's simply not feasible anymore. I know most parts of the workflow and the life cycle. From data engineering to research to model development to MLOps. I understand all of them. However, I am not an expert in all of them. And I couldn't be. Really, after 2017, I think, it became impossible to be a unicorn. So data science is a team sport. That has a lot of implications for us as data scientists. It means that to a level, we have to choose an area of focus, whether that's data engineering, data curation, data science itself, that research process, model development, ML engineering, or ML ops. the observability, continuous improvement, that reliability and quality assurance focused area, those four are so big in and of themselves that there's no way for one person to successfully handle all four of them in any sort of application that has to scale, that has to survive in production over a long run. It just can't be done. Data science is the absolute perfect name for what we do, because the two most important things are data and science. We have to understand the data, and I think that's very well understood in our field. Science. We do science. Anytime you build a model, you're running an observational study. A lot of data scientists don't understand rigorous research methodologies, don't understand study design or experimental design, don't understand experimental management, how to evaluate results, how to go from very basic descriptive models to your prescriptive, diagnostic, predictive models to eventually using causal methods, causal approaches to build for high reliability use cases. That all requires a scientific understanding. And when we don't have that, we deliver overextended data and overextended analytics. We say this can predict something and it doesn't. That ends tragically because frontline users rely on this data that we're providing or the inference that we're serving. They expect it to be more reliable than it actually is. And when it fails, costs the business a lot of money or costs them credibility with customers. Data and science are equally important. No one adopts what they don't understand or don't trust. I think data science's most significant weakness is the complexity and the lack of transparency. Part of my job is simplifying the solution to the point where all that complexity happens someplace else, that people, users, frontline workers, the internal customers and external customers never see the complexity of the model. The model makes their lives easier. The model makes them more successful. Or if their customers provides value to them in a new way that traditional software simply was not capable of accommodating. But all of that complexity, all that deep learning or whatever I've done, all the experiments, everything, that's all hidden. If they see complexity, they will not adopt it. And going back to talking about data and science being equally important, if I don't create a highly reliable model, if I don't make those extra steps and extra efforts to create a body of evidence for the way that it will function across the range of scenarios my users expect, back to knowing my users as well as I know my data. If I'm not successful there, I don't establish trust, and I probably will lose it. Because when that model fails, users abandon it, and getting their trust back is not easy. They won't adopt it unless I do the work to make it transparent, low complexity, and highly reliable. Make them trust the solutions that I'm delivering. This one was big for me. I'm accountable for delivering value, not technology. As soon as I made that switch, where the technology was the second most important thing that I delivered, and value was the major thing that I delivered to the business, everything about my way of working and approaching problems changed completely. It doesn't matter what the solution is. If I can use a paperclip to open a door, no one's going to be upset about that. If I can use a report, SQL query, to deliver value, no one cares that it took me 5 minutes versus 5 weeks building a machine learning solution. No one cares. They just want the value. That's it. There's nothing else involved that's important to them as users. When we look at this stuff, the cooler the solution, the higher the value to us. But to users, it doesn't matter. If I can provide them value in a simple wrapper, quickly, low cost, all of those things that's what they care about. My job is to provide value, not technology. And I became technology agnostic as a result. I will use the simplest methods. I will try 4 or 5 things before I even turn to a model of any complexity. Before I get to machine learning and deep learning, I have tried a lot of other approaches to eliminate doing something that's far cheaper and far simpler. I've made sure that the only way I can deliver this value is with some expensive and time-consuming technology, because they don't care how I do it. They just want it to work the way that they need it to. And that's it. Last one. This one's also huge. I've saved my most important ones for the end. I should say no to most projects because they can be done just as well with traditional software or analytics. This really goes back to that last point. It's an extension. When you realize that you're accountable for value and not technology, everything that I do, should I be the one evaluating whether this is better for software? No, I should be handing that over to somebody else. Should I be evaluating whether or not this is a candidate for an analytics basic descriptive modeling solution? No, I should be handing that off to somebody else. Saying no is powerful because now what it forces is the highest value opportunities are the ones that I'm going to be working on. Those initiatives that no other technology can handle. No one else can deliver this type of value except a data scientist using machine learning, deep learning, experimental methods, or causal methods. If it can be done with something else, it should be. Because my time should be spent doing those things only I can do. Why should I be a software engineer when we have far more capable software engineers already available? We have great data analysts who are, for the most part, underutilized. The amount of value a data analyst can create is massive. And when I realized that handing off projects doesn't threaten me, it actually makes me more valuable because now, what am I working on? I'm working on the stuff only I can do. What you'll find is those projects have the highest return on investment for a data scientist's time, and for the business, they create competitive advantages because it's something that other companies, for the most part, can't do. Companies struggle to prioritize, to figure out what projects they should be working on, to get data scientists onto those projects that no one else should be working on, and get them into production. Back to that top one. So if I can work on the right projects, if I can have a good heuristic for project selection, and I focus on the user, I focus on delivering value, not technology, if I gain trust, build reliable solutions using best practices, using those scientific methodologies, and I can get it into production, I can do something for the business that most other businesses cannot replicate. That's an advantage. It means we can deliver value to customers or we can produce value internally in ways that other businesses can't. So those are the big points that in my career, these have been transformational. And I think if you internalize and incorporate these 7 principles into what you do as a data scientist, you're going to be significantly more valuable and it will change your career.